Hey guys, so today I'll be going over one of my favorite coding questions, and that is climbing stairs. So in climbing stairs, you're supposed to find the number of distinct ways to get to n steps. So the only caveat here is you can only travel 1 or 2 steps. So let's say for instance n was equal to 3. So how many distinct ways can you get to 3? So you can go 1, 1, and 1. Here's one distinct way. You could go 2 and 1. There's another. Or you could go 1 and 2. There's another. So that's 3 possible distinct ways. And the brute force solution would be to check all possible distinct ways, which is basically what we did there, and then calculate that through recursion. And that solution gives you a runtime of 2 to the power of n, which is very inefficient. So what we can do instead is use what's called dynamic programming. So dynamic programming is when you split the problem into a bunch of smaller sub-problems, use those sub-problems to find your answers. String up all those sub-problems together to find your answer. So let's do that here. So we saw that the number of distinct ways to get to step 3 was 3. So the number of distinct ways to get to step 1 is only 1 because there's only one possible way. Step 2, you can either go 1 and 1 or just take 2 steps. That's 2. For step 4, you can either go 1 and 3, 2 and 2, 3 and 1, 1, 1, 1, 1, or 2, 1 and 1. So if you were counting the number of distinct ways, that was 5. So the thing that you'll notice about this is there's a pattern. So this is very similar to the Fibonacci sequence, where the previous 2 numbers are used to calculate the next number. So we can see here 2 plus 1 equals 3, and 3 plus 2 equals 5. And if we continue on with this pattern, we get 5 plus 3 equals 8. So we don't even have to calculate how many distinct ways there are for 5 steps. We can just add up the distinct ways for 4 and 3. We can use an array to store all our answers, and each answer is a sum of the previous 2 answers. And to do that, we need our first 2 base cases. So in this case, we had to calculate the number of distinct ways there are to get to 0. And this one's kind of trivial, but we just put 1, make it that the pattern stays true. So if we move on to how many distinct ways there are to get to 1 step, that's 1. And then now we can add 1 and 1 up to get 2. And then we can continue on with the pattern 1 plus 2, 3, and 2 plus 3 is 5. And you'll see the code on the right here. We can start at this index because we already know the answer of first 2 indexes, right? And we would loop through, and then this line of code right here essentially adds the previous elements together. So that'd be 1 plus 1. And then it would store 2 in the current index. And then it would keep going until you reach n plus 1 steps. The reason you do n plus 1 here is because Python is inclusive and then non-inclusive. So 2 is included, but n plus 1 is non-inclusive. It just loops up to n plus 1, not including n plus 1. So if we don't put the n plus 1, we'll be missing our last element here. And what you'll notice is the last element is very important because that's essentially the answer that you want to return. So eventually you'll get to a point where I is equal to 4, and then the DP array will be calculated by adding 2 and 3, and then you get 5, and at which point you exit the loop and you return 5. So 5 is your answer. And this solution has a runtime of O of n, as well as a space complexity of O of n. Thanks for watching, guys, and I'll see you in the next one.